I'm a professor at Harvard University, Harvard Medical School. I'm by training, I'm a physician, not a PhD. I'm by training a pediatric hematologist oncologist. I ran a bone marrow transplant unit for a long time. My research is in stem cell transplantation, particularly in rejection and immunologic sorts of issues where we've developed some novel therapies, and more recently also in the lab working on what's called radiation mitigation, so really an agent that we could take to protect us should Fukushima or Chernobyl or such an event happen again, which it inevitably will. And all of that sort of translational work really, I think, put me in the position of thinking about how redundant our research activities are, and how ineffective and how unlinked they are, so that people are always sort of starting over again and don't get much opportunity to benefit either from knowledge in their colleagues or from the accumulated knowledge getting passed on. That led me to working in a program which I will introduce to you somewhere in the middle of this, called the Harvard Catalyst, which is a translational science engine of sorts. And thinking about how different sorts of approaches, which we could encapsulate under open innovation, could be applied to trying to advance that kind of science to populations and individual patients more rapidly, make the work process more efficient, less redundant, and more fun. And I'm going to show you some of that work today. And the way that I'd like to proceed today is really through a series of very brief examples of some of the major topics in open innovation, and I'm sure that a lot of these are things that you're going to be seeing elaborated on as you move through your modules. So this is by no means comprehensive, but it's by way of introducing some practical applications in this sort of work. So let's see how we do. So the goal of what we've tried to do at Harvard with these open innovation strategies is really trying to increase the impact of our research by integrating these strategies into how we do our work. And this is a list of what I think or a bubblegram of what I think some of the central concepts are that we've tried to explore. And there are lots of different concepts that you can elect to look at. And I think part of the issue in selecting a research program of your own or in doing work is to pick which of these issues you want to focus on and to make very deliberate decisions about what it is you're trying to learn. Is it something that you want to see in practice? Is it something that you want to study academically? Is it something that you want to understand how a group formulates around that idea and explores it collectively? So the first message really is that in even selecting the approaches that you want to use or learn about, you need to make a decision about what it is you're doing with the topic. I mean, are you playing, are you publishing, or are you practicing in principle? And this can be along a number of things. But we had particular issues around how we formulate the kinds of questions that we want to get out to the public and to our peers, and how we deconstruct those problems and present them, how we find new participants, and in particular for thorny scientific problems, what's the community of people? Who are the other solvers that could help us? How do we incentivize people to participate in these sorts of collective experiments or in these collective processes? I mean, people don't have infinite amounts of time and they have lots of self-interest. So how do you actually get them to come and address the questions that you're interested in or that you believe are important to a particular community? And we've tried a variety of different kinds of incentivization programs. I'll show you that. What are ways in which you can encourage interdisciplinarity, and where do they fail and where might they be successful? How do you think about evaluating projects as they go along, both in terms of selection and in terms of understanding whether they're productive, and a bit about program management at the end? Okay, so I'm going to go through three concepts, actually, very, very briefly. You will hear about them, I'm sure, in more specific detail, but just to make sure we have some common knowledge. And then to illustrate the idea that you can actually take on an idea in open innovation and examine it in a very practical and concrete sense, give you a couple of examples, including some work that's actually ongoing currently. So first of all, I'm assuming or hope that many of you have heard about the long tail of innovation, and this is a really crucial concept. It is perhaps one of the most underlying concepts, really, in all of open innovation. and it's a very old one, and that is that if you have a problem, what's the best way to solve it? So the best way for you to solve a problem that you have right now is to turn to the person next to you, and if they have expertise in your problem gets solved in 2 minutes, right? It's really easy, it's facile, it doesn't require much energy or investment. So, local solution, if you have some solvers available to you that are close and that are local, is probably fast. The problem is when that doesn't pertain, and for many complicated problems in science, it really doesn't pertain. So even an institution like Harvard, which is really very large and sends a paycheck to about 40,000 different people, you don't necessarily have all the expertise for your particular problem local to you. And even if it's local, it's only local in a generic sense. I mean, someone who's across a river and 4 miles away from you isn't very local. You can't simply turn to them and ask a question. It requires a certain amount of investment to get to them. So you need to sort of be able to stretch out across disciplines. You need to be able to stretch out across geographies to increase the number of solvers or just increase that area under the curve of people who can help you. So that's the long tail. It actually is a tail in both directions, although people often don't say that. So how do you use the long tail of innovation, and what are its sorts of problems? So there are, I think, 2 kinds of concepts that are important. And one of them is what's called Joy's law. And this is really an interesting reflection on why innovation is really bounded if you stay local, if you don't walk out that long tail. So Bill Joy was the head of Sun Systems. He's a really seminal person in the involvement of a lot of both software and hardware development, actually also super smart. And he said famously, no matter who you are, most of the smartest people work for somebody else. And that's always true. It doesn't really matter what you do, right? There's always somebody who's smarter and they don't live right next to you. And that really is why you need to walk out those tails if you want to do something that's really new and that's really difficult. Oh. And don't stand over to that side because this won't work. There we go. So what are the explanations for Joy's law? And again, I think very briefly it's worth thinking about this. First of all, knowledge is unevenly distributed. True, right? All knowledge is not distributed equally in each room, in each space, in each country, in anything, and said by one of your local denizens here. And second, that knowledge is sticky, that it doesn't really like to travel. It's not simple for knowledge to actually diffuse across populations or spaces. It's sort of resident with the people who develop it and where it's being applied. So it's not equally accessible. It's hard to move it. It's easier to move yourself to where it might be. And this is an interesting, I think, illustration of how we don't really think about this correctly. So Bob Langer is a really very famous famous everything. I mean, he's just a brilliant person in materials science and in the development of medical devices, among other things. He works at MIT, and this is an interesting networkgram that was done of Bob's work in this period of time. And what they were able to show, these are people who co-published with him, is that Langer's lab itself, and Langer as an author, was associated with half of the other really prolific authors in this sort of burgeoning space of using new materials, bioscientific research. So you'd say, okay, this is somebody who's really well networked. This is somebody who's walking out that tail of disciplines. He's going to lots of different people. So he's going up and down. He's got a great area under the curve. He's well situated for innovation. And he innovates openly. Now, if you go ahead and then look in the next small era, his field is really burgeoning. And all of a sudden, if you look at the most prolific authors, Dr. Langer's lab's only associated, very short period of time. He falls from about 60% of people down to 40% of people. So is he becoming less efficient? Is he becoming less good at open innovation as he gets older and established? Is his work getting more focused? And that's what people were saying, except look what happens if you do this the right way. So the question is not, when you work, are you working with other famous people? It's not, are you working with the most prolific people? It's, are you working with the people who are the most suited to help you answer your question? It's a different way of approaching what it is that you need. And in fact, that's exactly what happened. So as the field grew, as knowledge became more sticky out in the periphery, as the number of people who had potential solutions for Dr. Langer's problems became more diverse, so did his outreach to those people. And in fact, if you look now, not at the most prolific, but if you look at all the people who published at least some of the time with Bob Langer, it becomes almost infinite. So this is a man who completely takes advantage of that area under the curve in terms of the diversity of his work. Could we then use that kind of principle and that sort of teaching to try to renovate a specific problem at our medical school? And I'll show you where we did. So we just sort of mentioned that there are lots of these things that make getting information, establishing collaborations, and collaborations are necessary to information transfer, right? So there are lots and lots of problems. Can you overcome some of those problems? And we tried taking on that issue and several others in the context of the Harvard Catalyst, and this is a large grant and initiative that's led by my colleague Lee Nadler, who's also here with me. This is also called the Harvard Clinical Translational Science Center, and these were centers that were established by our National Institutes of Health, our NIH, as a national. There are around 60 of them across the country. This, for us, is a pan-university organization. Harvard's got 10 schools. It's got 16 large affiliated health centers. This is a large number of institutions, and its mission is listed here: to accelerate the translation of discoveries from the bench to improve human health. All right, there's probably a better way I can point this and make it work, but I haven't quite figured it out yet. Ah, okay. So Harvard's kind of a weird place. We call it one university, not united. It has been said that it's 14,000 independent contractors working in one place, and that's true. We don't work actually in a structured or particularly well integrated way at all. Everybody's sort of on their own. All the researchers have academic affiliations with Harvard, but they're actually not employed by Harvard. Virtually no one's employed by Harvard. People are employed by the separate institutions, who are all separate institutions in every sense of the word. They have independent governance. They have independent IP arrangements, grant arrangements. They appear as separate institutions in hospital rankings in the United States. They actually directly compete with one another, even though they're part of the same central system, for resources, for people, for dollars, for recognition, for NIH dollars. And this is a cartoon that, you know, sort of makes a joke out of the fact that people working exactly in the same space may have no idea what each other is doing. And this is actually paradigmatic of my working environment, because in my environment, collaboration is really very rare. The likelihood the two HMS, so Harvard Medical School faculty, those people I just mentioned, will actually co-publish with one another. Now think about this if you're setting up a large enterprise, is 0.06%. So we certainly don't take advantage of multidisciplinarity even locally. In fact, we're astonishingly bad at it. So the rationale for our first field experiment was that collaboration was amazingly low, that interdisciplinary research wasn't encouraged, that finding others to leverage your interests is hard, finding resources is difficult, this limits our innovative output. Could simple steps improve things? And the issue here wasn't so much collaboration per se, it was really trying to do an exercise about understanding whether we could come up with any leverage that would force people along those sort of indices of the tail of innovation. So it wasn't so much a sociology experiment and whether they would work well together, it was could we even move them to find each other? Okay? All right. So very briefly, this was an initiative that we called Using Imaging to Transform Medicine. It was a field experiment in collaborator matching. So we had about $800,000, thanks to Lee, for $50,000 grants. So we were looking to incentivize up to around 12 groups of people to work together. And we wanted to put together new pairings. So what we did was we reached out specifically to clinical people, to clinicians, and said, do you have a problem? Can you formulate a problem that novel imaging technology A, B, or C could address? PET or optical coherence tomography or MRI. And then how would having that help you? And then we asked people who were imagers in those three areas, you know, you have this imaging technology. Is there something else interesting that you'd like to do to it? Do you need clinical partners to understand how your technology works? So we asked the people on both sides of that divide to separately define needs and problems that they might have with the view that we would bring them together in an event and see if they each displayed their problem, whether we could actually increase the interaction between people, because there might be similarities or complementarities that those two groups of people who don't necessarily see each other on a regular basis would be able to cohere around. And we did that through the means of 3 identical symposia held across 1 week. We had a total of 400 participants, because if you wave $50,000 in front of people, that's a big incentive to at least show up over in a space called the Innovation Lab. This is the way that this worked, but in principle, this is about 150 people a night, 130 people a night. When they showed up, they were randomly assigned to one of 4 work areas. So it was completely randomized. And in that work area, what we did, we had these sort of oval rooms, is along the outside of these rooms, we put up posters. And the posters were the statements that we had asked people to provide to us in advance. So this was a statement from either an imager or a clinician that had on the top, "This is my question. This is why it's important. And this is how an answer would transform my research." 300 words. We did all the posters. So this isn't like when you go to a poster session, the person who's got the prettiest pictures gets 300 people looking at them. The person who's got the ugly poster, nobody stops. We sort of took that out of the question. We printed up the posters, we printed up the answers, and I'd be happy to talk to people at another time. And some of you heard me say last night that actually asking people to define what they need by formulating a single question is probably the most interesting exercise that I've ever undertaken, and what I found out is that people can't do it. They can tell you what they think, they can tell you how they'd like to impress you, they can make a statement. What they cannot do is formulate in one direct sentence what their question is, and this is 400 really exquisitely good scientists. They don't do it. So we are particularly poor, we are stunningly poor, and I have now asked around our medical area, and there are actually any number of other people who say the same thing, at actually formulating what our questions are. So this is a skill that we need, because if you're going to work in an open innovation way, if you want to query the community, if you want them to understand your questions, then addressing this issue of how we formulate and convey information and how we have clarity about what we want and what we expect in an answer is very important. At any rate, we put up these posters around the room. So first we put up the clinicians' posters, we put up a mixture of the posters around the outside, and the people who had those were group 1, and they stood in front of their posters, and the other group circulated around for 45 minutes. And we took a break for 15 minutes, and we flipped the posters, so now we had the other half of the posters up, and we changed who was walking and who was standing. So that was sort of the forced interaction. Who was in each room was random. And then at the end of all of this, we tried to make sure that information globally was available to everybody. So how do you conventionally get information? You have a computer system, we made that available to everybody. We printed up each of the posters, we gave it to all the 400 people. We gave a list of the attendees, along with contact information, to all of the 400 people who were there. We told them, you know what, you told us what idea you had. If you came here and you got excited by somebody else or something new, you can submit that for the grant. You don't have to stay with what you came with. We told them they had to have 2 collaborators to make it pretty clear that we were interested not just in one person, but in more people coming together. We told them that actually the applications would be double-blinded, that people wouldn't know what the groups were, so that there wouldn't actually be any prejudice by people saying, these people have worked really well together before, I want to give them more money because they're productive. We tried to make it as bland and as open as we could to see whether or not there was any evidence that simply putting people together, discussing their problems in a controlled way, made a difference, and stunningly it did. Some people who nominally work at the same institution and who work in some cases in similar disciplines, simply being randomly put in the same room for an hour and a half, how embarrassing is this, by the way, increased the likelihood that they would collaborate on a research project by 70%. Now, what this actually says about the way that people reach out to one another and the degree of interest that they have intrinsically or capacity that they have for finding partners is pretty stunning. So, you know, we lowered those search costs for very random subsets of individuals. So that's who got into the room. Also randomly, which night did they show up? I mean, there was very little deliberation yet. And yet, this made people come together with a coherent project that actually passed a pretty elaborate peer review to get funded. We also were able to look at where simply putting people in a room together had the biggest effect. And I personally think this is pretty fascinating. It was people who were in the same room, who were working in the same general area, so imagers and imagers. If the pairs included a woman, the same room and having published together in the past. And what's another way of thinking about all of this? And I'm going to get to what those are. I know I walked past it quickly. Coordination costs matter. So, you know, finding someone, the friction of finding someone, a collaborator, is higher than we perhaps think that it is. There's a lot that's written about that. And that some pretty simple things can overcome that, at least in part. Looking at the pairs that led us actually to understand a bit more. So it was very interesting. We thought that what was going to happen, what we wanted to happen, was that clinicians and imagers would come together to solve an interesting problem. It's actually not what happened at all. What mostly happened were that imagers came together with other imagers, and we weren't actually that interested in those problems, but those were the things that formed. And, you know, why is that? So, for one thing, imagers probably shared more information to start with, so in a short period of time, maybe it was easier for them to communicate. And those brief discussions were more fruitful. Maybe it was harder for clinical people to switch from one clinical area to another. Maybe it's the technologists are closer to engineers, and engineers have been studied frequently and shown to be more open to a variety of things and sort of more open to less structured kinds of thinking. You know, we don't really know, but it was clear that it wasn't an equivalent outcome. The fact that people who had authored together came together and put together a completely new project was really very fascinating. So is that they were comfortable with one another? And so they could sort of fall into that, maybe. The other thing that was interesting was if they had such a striking interest that they had to put together a new grant, how come they hadn't done it before? They knew one another. They could have done something that interdisciplinary before, but they hadn't. So even when these ideas are available to us and we have pre-existing mechanisms for addressing the questions unless we're pushed, we don't necessarily do it. And the last thing, of course, was this preponderance of women, and that the way that people are able to establish networks and pull projects together may be, like many other things, gender biased. So these aren't, and I by no means mean to show you anything that's completed here. What this first illustration was that you could, in a relatively simple way, and in the context of some of the things that you're working on, put together events or exercises, and you'll be doing practical exercises at your institutions or in your groups that allow you to start to feel what the edges of some of these problems are in your own community, with its own limitations and its own strictures, that can then inform you about how you might move forward. Because you can think for yourselves, all of you, with this information, what might you do as a next step if you wanted to actually change the framework of how people came along. The exercises are not complicated and the analyses are not complicated. You can start to sort of get your hands around some of this and think where you might go. Okay. It also gets more complicated, though, because not all of our potential collaborators are even close to local, so call it Austria, right? There's a much larger community, and now there's also a whole set of other communities that we before couldn't even palpate. So this is a letter that I got the day before I left to come to this meeting from a collection of bioinformaticians who are selling their services to do analyses on your primary research. And what they're saying basically is, you know, you may or may not have great bioinformaticians at your institution, and they may or may not be available to you because they don't have time and you don't have money and they have their own academic needs, but we are here, accessible, friendly, efficient, and unbelievably cheap. And we will work with you to do your analysis. So now my crowd just got a whole lot bigger and a whole lot more diverse and a whole lot more complicated in some senses in terms of decision making. And then you've got lots and lots of virtual companies that you can also work with in virtual platforms. I'm going to show you how some of that works. All right, so I want to go to a second concept and show how we then integrated thinking about the long tail with this. So this is something that's called extreme value outcomes. And most of us actually are not really interested in doing well, actually, I should say, most of us spend our lives doing incremental work, right? The way that science traditionally has gone is really by this sort of incremental progress. But what people really hope for, and mostly what we need in things really, is that sort of big jump, is the extreme value solution, right? Not going to go to a lot of effort to improve the ability of my sensing equipment to go 1 more centimeter into the ground, right? If I'm doing an archaeologic thing, but if somebody can actually give me the spectra on all of the materials within that 1 centimeter, that becomes more interesting to me. If somebody can go down 2 miles, that becomes more interesting. So what are the really huge jumps in technology or solutions? So those are extra value outcomes. How do you get to those places where you get extreme value? And to look at this, we actually, to do 2 things actually. To think about the long tail plus extreme value, we did the following experiment. So this was a contest. This was how you sort of think about where competitions can be integrated into your work in academic biomedicine. And we wanted to do a lot of things. So people aren't used to the idea of competitions. I mean, the X Prize is one thing, but the idea that Harvard as an institution is going to start offering people money to give them solutions for their scientific problems was pretty darn foreign, that you'd use someone you didn't know, that you couldn't see, you couldn't touch, admit that you couldn't actually come up with solution locally. And render it up was a very difficult idea. So we wanted to provide an example of the community. We wanted to address the feasibility of sourcing and framing a problem with a virtual network of solvers that you knew nothing about except that they were not in your field. We wanted to demonstrate how good they were. We wanted to come up with a practical, concrete, and significantly better solution. And we wanted to unequivocally show that community could do better than a highly trained, highly specialized, highly dedicated, and well-paid academic community that considers it the elite of themselves, the elite of the elite. And we did. And we did this through a wide and active broadcast to a very untraditional solver community. That solver community was Topcoder, which is a virtual community of software coders. They have a competition base. They're paid on the basis of their results. They're paid not a lot of money for any individual solution. There are about 500,000 software coders who are signed up, who work on this virtual platform at this time. There are around 250,000 at the time that we did this. And what we decided to do is to work in algorithm development. So our objective, and I heard there are a couple of molecular biologists in the room, was to improve on a 10-year-old algorithm at NIH called Megablast, which is about sequence annotation. So this is really, you can sequence amino acids, you can sequence peptides. Trying to line them up is a big problem. It's important for lots and lots of different kinds of science. And that algorithm, that site, is used internationally to do sequence annotation. You submit your data, it gives you back answers days to weeks later, and you get in line to have it happen on a mainframe that sits down in Washington. So the experiment was to generate and evaluate the Topcoder solvers in the development of a different sequence annotation algorithm in a very specific setting, which was looking at the sequence of peptides of amino acids, in immunoglobulin and antibody genomics. Now, this has been the subject. First of all, this has been up there for 10 years. We have a local researcher who's really top of the game in this. He's had NIH funding, so 3- and 5-year chunks of funding to do this for 10 years, and had, in fact, made significant progress. There's also a person at Stanford who had made some progress in this, but not very much. So we had a local sort of best guess. We had this sort of as an international standard, and those things had taken years of research and, many of hundreds of thousands of dollars a year to set up and maintain. So we decided we really wanted to press this. We did a 2-week competition, and we incentivized it with $6,000 total dollars. And it wasn't even a $6,000 prize. The prizes were divvied up in sort of small chunks for incremental progress over the course of the 2 weeks. So it wasn't very much of an incentive. What did we see? This is what we saw. This is the NIH solution. So going up is more accurate. Going out is longer. What you want is short and accurate. You want to be here. All right? So here's the NIH. Pretty accurate and really slow. Here's the local best solution by the guy who's been getting paid to do this for the last couple of years. faster, a little bit more accurate. Here are competitors in 2 weeks, okay? And these were the top 10 or so competitors. They're all way faster. This is a log scale. They're all way faster, and they're all more accurate. And they did it because they were interested. So, you know, rather than having given this guy $200,000 grant for 5 years, which is an R01, in principle, somebody got $200. And in 2 weeks did this. And the thing that's really interesting about this is that it wasn't one person. The thing that's fascinating about this is that the top 34 people exceeded the state of the art by 10 to the second to 10 to the fifth. And more fascinating than that to me is that 89 different approaches, we analyzed this with some help, there were 89 different approaches. It wasn't that there was a solution, there were 89 different kinds of solutions that no one had found. So when you talk about the long tail and you talk about extreme value, it's not like you're out there looking for Leonardo da Vinci. You're just saying these are complicated problems and you're trying to come up with a better solution than you have locally. And by engaging a different community and different sorts of expertise, you can get there. So you're going to say, all right, they had 500,000 people. There must have been a lot of comp bio people who are trying to come home with a bigger paycheck. Actually, there wasn't a single academic solver who put in a solution through this database. And there wasn't a single biologist and there wasn't a single computational biologist. So it wasn't that they had the pre-existing expertise, and you can see the winners were from all over the place, and even at a place as large as Harvard or the University of Vienna or Salzburg or Graz, what you don't have is this sort of diversity. And so diversity really matters, and it gets you extra value that you can't get locally. Can you do this for a different sort of problem? You're saying, okay, that's a very specialized skill set. So here's something that's no skill set. Type 1 diabetes. Could we get new ideas about type 1 diabetes? And this is just this beautiful statement by Einstein about the value of actually framing a question and coming up a new question. And this was actually a contest that we ran across the 40,000 people at Harvard, plus the international community through some postings in a variety of magazines and on the web. And the question was simply, diabetes is a huge problem. I mean, we framed it more beautifully than this, but in principle, can you think of anything in terms of prognosis, diagnosis, rehabilitation, maintenance, diet, I don't care, anything you can give me about diabetes that should be investigated, or frankly, an old idea, can you give me a new justification for going back and reinvestigating it to try to change the lives, ultimately, of people who either have now or will develop diabetes? So this was a widely communicated open call. We involved our university president who endorsed it, so that was hugely helpful. We told people they could do whatever they wanted, and then we said, and by the way, you don't have to reduce it to practice. I want your ideas. I don't care if you know how to make it real. I don't care if you know how to do the experiment or build the gizmo or build the network. I just want to know what kinds of thoughts we've been missing. This is a hard problem. We've been knocking our heads against it for a long time. Progress has been really infinitesimal in the past 10 years. And again, we incentivized this with some money just for the prizes. We got 150 pretty sensible proposals, and I just want to make 2 points about these. Not anything about the value per se, but could you get new ideas? That was actually the only question that we cared about. Could we get anything that was new? Could we get new solvers? Could we engage communities? So remember, this can be a patient, this can be a family member, this can be the secretary in my office, this can be my boss at the hospital. So this was our entire community, as well as the international scientific community. These were the highest academic qualifications of the people who responded. So on the left hand here are the people who usually get asked these scientific questions. So these are the MDs and the PhDs. But half of the people who responded, people who just went to high school, people who had some college, 2-year college, 4-year college, master's degrees, those aren't the people who normally have a voice in trying to design and resolve our scientific questions and set our scientific agendas. So half the people who contributed were really from out of the norm, and that was important to us. And this was another lesson. Virtually half of the people had someone in their own family who had diabetes. So also when you do this, you get those people who really, A, they have real knowledge, and B, they really care. They have a really a priori commitment to trying to actually make a contribution. And then the second was, were the ideas themselves any different? And I'm not going to take you through this in the interest of science. I'd be happy to discuss how we did this. But we actually used, there are mesh headings. Those are the headings for medical literature by which it gets filed in the National Library of Medicine and other sorts of, Google-type searches. So these are the medical subject headings. We took that subject heading analysis and we had it performed on all of these submissions, the 150 submissions. And then we went through complicated Monte Carlo sort of like poll where we looked at those headings and we compared them to the headings in the literature on diabetes. So, that's millions of headings in the literature, and the headings that were on here over the past 2 years, the past 5 years, the past 10 years, in diabetes, outside of diabetes, whatever. If you looked at the diabetes against the diabetes, what you saw was in our submissions, there were all kinds of words that weren't anywhere in the literature at all. And those are topic headings. It wasn't that they wrote blue, and that's not in the literature. Those are things that are actually medically relevant headings. So in fact, they were very, very different than what was already in the literature, which was about the most solid measure of novelty that we could come up with. All right. But you can already see, now if my objective had been in this, per se, to say, okay, is this an idea that I want to go forward with? And in fact, that was something we wanted to do. Now we have the next problem. So what happens if you do a contest and you have money and you want to fund ideas? So these ideas come in. I think some of these may be really interesting. I want to evaluate them. I want to give people $200,000 a piece to go do something with these cool ideas. What are you going to do? How are you going to evaluate it? Anybody got an idea? Anybody have committees locally that evaluate your work? You have professors, you have department chairs, you have the NIH, you have the University of Vienna's got a committee of professors. You have National Funding Agency, you have Ludwig Boltzmann's committee of evaluators. What do you think the likelihood is that those people are going to know how to look at really novel ideas? Is it great because that's what scientists do all the time? Maybe so. I don't know. This is one of the tenets of innovation, that what really matters is the quantity and variety of ideas, and that's what we're talking about. We talk about that all the time. You already heard about that in the introduction. We need to increase the flow of ideas. I told you we need to increase the flow of people into the system. And somehow that's going to take care of this, because if we load it up front, we're going to have more good stuff coming out the end. I don't think so, personally. What I think is it's a much bigger problem. And I think the problem, actually, massively, and as an under-identified issue, is in evaluation. Because if I load the system and I leave the filters exactly the same as they were, then my personal opinion is that what comes out the end is going to be exactly the same. Because those filters are set historically and by discipline. So something, in my view, needs to change about the discipline of evaluation as well. Because we don't actually know very much. Actually, we know virtually nothing about how well we evaluate. And it's actually great. In the last year and a half, 2 papers have come out about evaluation, about this very topic. The first sort of new literature on this in a while. So one was a paper by a woman named Danielle Lee, and they looked at a massive number of things that had gone into the NIH proposals, and then they looked to see whether the evaluation groups, conventional evaluation groups that we think of as looking at scientific novelty, whether they had appropriately evaluated them. And they used for appropriateness that they were productive, that people were able to get more grants, they published papers, they got patents, all this stuff. And they published to great acclaim that, in fact, the system works. And those papers that were higher ranked went on to do better work, and the grant proposals, not papers, grant proposals from people who were lower ranked actually didn't do very well. Now, there are huge problems with this analysis, but this met with a lot of affirmation by the community. Okay, new paper comes out about a month and a half ago. And in that paper, they did what I think is much more pertinent. They said, you know what, people submit a lot of stuff that's no good. This doesn't help, because we all know what the bad stuff is. So they said, we want the top 20%. So they took the data, they reanalyzed it, and they said, okay, we want the grants that were scored in the top 20%. If you're in the top 20%, the likelihood that you get funded is relatively high. And they said, in that 20%, If you then looked at the top 20%, does the ranking of the top 20% have anything to do with what ends up happening in the work? And the answer is nope, not so much. So people were able to actually distinguish the wheat from the chaff, as it were, the good from the bad. That's a good thing. But they actually couldn't tell what was actually really good and what was okay good at all. So the concept of peer review as we have it for our scientific work actually can distinguish that most innovative, most important thing from the thing that's kind of incremental. And we need to think about how we deal with that. So why do we care? Because peer evaluation is shoving around a heck of a lot of money in science. And those are just sort of a few of the facts about it, and that it's really understudied. So we tried to actually take a little look at this inside of our own experiment, and we were really motivated by this. So Mario Cappetti, the University of Utah, it's a great example. This is a grant that he proposed in 1980 for 3 projects. 2 of them were incremental, and 1 of them was really revolutionary. He proposed that you could create knockout mice, which was a really novel idea. Knockout mice didn't exist before that. And he was evaluated at the NIH, and they unanimously wanted to fund him, but only if he dropped Project 3. So they thought this was really great science and that this sounded ridiculous. So he was funded in the belief that he was not going to do Project 3, and he took the money and did Project 3. And as he said, you know, gee, I was lucky it worked, and went on to win the Nobel Prize. But so much for peer evaluation of novelty, right? It's not that it's bad, it's that it's imperfect, and this just gives you a different sense. We actually took the 150, and there are actually 150 lines that start right here, the 150 diabetes projects, and we gave them to a group of venture capitalists. We gave them to the Juvenile Diabetes Research Foundation. These are the biggest funders of diabetes research in the world. We gave them to Harvard full professors who are experts in diabetes. We have 14,000 people, so we had 30 experts. To junior faculty in diabetes, to people who work with diabetologists but don't themselves do diabetes, so they're kind of next door neighbors, and people whose work has absolutely nothing to do with diabetes, and we divided them up as junior whatever, and we found 30 people in each group, so now we've got 8 groups, we've got 30 people, we got 240 people. This is the largest grant review that's like ever happened, and we permuted these, and if you follow these lines, you get a sense, just like Danielle Lee's paper, that, you know, better is red and worse is blue, that in general, it's more red near the top, it's more blue near the bottom, but you notice that there's a heck of a lot of purple in this kind of Jackson Pollock-like thing. Whoa. And if you actually, let me go back one more, if you actually do something where it's easier to see, and we just take the top 10, and we graph those, you can see that here are things that the VCs thought were great, and the people at the biggest diabetes funder in the world thought were terrible. Here are things that, you know, the type 1 diabetes experts thought were exceptional. These people, who are these people, thought they were terrible. The VCs could care less about them, and on and on and on. So there actually, statistically, there was no pattern in these at all. In fact, the only thing that was steadfast in this was the number 1 in about 6 out of the 8 categories was actually work that had already been done and published, and people were supposed to be evaluating it for novelty. Okay. So we have a lot to learn, and this just suggests that even in our own sort of small efforts, at the same time that we're doing practical exercises, we can take the information that we generate to try to learn other things. And what we learned actually by analyzing this, and I just thought I would share this with you briefly, is that some of our prejudices about this weren't true. So one thing was true, which was that the more expert the reviewer was in the field, the worse the review. And when you really dove down into that, it didn't really look like it was because they were being protective of their own work. It really looked like they had the capacity to be more critical about it. So that sort of made sense. What was really striking, though, was that it didn't matter who reviewed it. It didn't matter whether it was the most junior, most disconnected person, or the most senior and most expert person. The newer the work was, measured by those words that had never appeared together before in the literature of diabetes research, the more everyone hated it. And that discount, the novelty discount, was uniform, and it was severe. And it was enough, if you modeled it, to knock you out of the funding range at NIH universally. So that when you actually propose stuff that people see clearly as novel, as different, the likelihood that you get a fundable score, regardless of who scores you, and our prejudice had been that more junior and less expert people would welcome novelty, and that was absolutely not true. It's a very risky strategy. This again gets back to, how do you incentivize this work? How do you motivate people to do it? How do you reward them for doing it? And how do you recognize it? Difficult. And how do you recognize it as being worthwhile? Just being novel doesn't make it worthwhile, certainly. So here was this is my last point, that, this was this sort of, we published this a couple of years ago. We thought we were very clever. We have small teams, we use peer experts, we have very few teams, so we said, okay, we need to walk out that long tail, we need to have more diversity, we need to have bigger teams, we need to think about how those teams come together better, we need to have more diverse research teams, and bingo, we will have more innovation. And what we found was that this was clearly not good enough. And there are many places for improvement, but I'm going to show you just one. And this is sort of a summary slide of what we then came up with as a work process, trying to think about all the elements that to date we thought we had identified, about how we did experiments inside of practical efforts to learn things, how you educate people, how we try to change evaluation, da-da-da. And we've concentrated a lot of that sort of circular, iterative, recursive work in the area of imaging technologies, because technology is attractive to people. It incentivizes them to come to the table. These are expensive things to have on your benchtop, and they don't have them, and they're new, and they're sexy, and we've run a bunch of different programs using that and some money as the pull to get people in. And we found something really fascinating, and that is that if you take people, you bring them in to do something new, and I suspect this is also true if you take people and bring them in to do something old, but I don't know because we haven't done that, and you give them the money, and you've put together this new team around this new and exciting issue, and you've enabled them with some new technology, and you leave them alone, and they're at a really good place, and they're really smart, and they've got a fancy title that they'll do good work, and that something interesting and innovative will come out of it. Or at least interesting and incremental. Actually, not so much. So we set up a bunch of these innovation exercises, and I want to show you something really interesting. Average project spend. Assume that, spending your money means you're actually doing work. Not very good, 30%. So at a time when money's really tight in US research, they spent 30%. So what do we do with this? And look at this. A third of the projects didn't even get their work started in the first year. A third of them needed no-cost extensions. A third of them started when they were planned to start. It was horrifying. And they weren't, for all that money and support and technology and assistance, they weren't really getting very far in terms of getting more work, trying to have continuation of their work. So we did something really revolutionary. We hired some program managers. We said these people can't manage themselves, they can't get their work done. We've been hearing this from industry for how many years, that we don't get done what people ask us to do. We got PhD program managers with real skills in program management, and we made them meet with each team. We told the teams they couldn't have their money unless they met with them. They had to set goals, and they had to show up with metrics, and they had to meet them. But more than that, our program managers also said, you need a different collaborator, and you need a different sort of facilitation. You need somebody to help you with image analysis, and we found them new partners in an ongoing way, and we helped them assess what they needed to be successful. And look what's happened. That's the only change, by the way. Everybody starts, everybody finishes on time, everybody uses their money, everybody's applying for new money, people are finding patents, people are getting manuscripts out the door. So there's the second sort of implementation part about trying to get to more novel things that's really important. And I think this is just sort of starting to touch on that topic, but how it then leads to the question of how do you really manage the innovative process in research without being intrusive? But how do you do that in a way that makes everybody happier? And I think that this is going to be critical when you're putting together more diverse teams, because these aren't people who have common knowledge. They're not people who have common language. They don't have a background together. They're looking at something new, and they don't know what the right metrics are, and they don't know how to reach out together. But someone who sort of can look at that from afar and who's adequately skilled, and what does that mean, and who are those people, can move this process along. But I think otherwise it's likely to founder. And in fact, if you look at a lot of these efforts at other institutions, it's what you also see. So there's also this management component of moving projects along that's going to be really important. So what have we learned to date? And I am unbelievably totally on time. I'm very excited. One is you have to sort of figure out what your institution's already doing so that you can really put those experiments into a context where they can sort of stay alive and prosper and people are willing to accept them. So we worked very hard to try to define things. That's why we use technologies that are resonant with our institution. So there's a local champion for having that stuff done, for example, or ideas that matter to a large part of the population like diabetes or like mental health. Think about what some of the basic ideas in the field are. I mean, those are ideas that have been evolved by a lot of people thoughtfully perusing a lot of evidence and experimentation, and think about how you can sort of use that to help you structure your own thinking about what you're doing. Getting the community to participate is really hard. And hanging on to them and keeping them involved in the process is also difficult. What's your outreach going to look like? Who's going to be your endorser? How do you deconstruct and frame questions? One of the most critical aspects of all of this. How do you actually make somebody else understand what's important about a question and also what you want to learn about the question? Those are different things. So clarity about that is everything, and this is a skill that virtually none of us have. Face-to-face interactions matter. Doing all of this virtually through a computer system isn't going to get you anywhere. You know, we gave people computer access, and yet simply putting them together in a room for an hour and a half got us a completely different set of collaborations. And that is by far not the only example of that particular learning. Intellectual distance, obviously, you guys are going to learn tons about interdisciplinarity while you're here. Evaluation is a bigger and thornier problem, I think, than any of us know. And since there's always an evaluation component of your work, either in selecting project and selecting, if you go to the community for input, it's only helpful if you know what to do with the input that you get. I mean, how are you going to think about it? How are you going to sort out the useful idea? And what does it mean to be useful? And if useful means productive, it's going to make something new. If useful means it's going to engage the community, those are probably two different evaluation processes. So you have to get really specific about what you're trying to do. Good ideas are not enough. With all the good intentions in the world and all the resources in the world, you still got to manage what you've got if you have a place that you're trying to get. So I would say the facilitation, program management are essential to innovation. Always think about the end user, and you will again hear in time, several of you mentioned this really already just in your introductions, right? Who's the community you're trying to address? What is the community you're trying to build? Who's going to use your product? Who's going to contribute to it? And then lastly, and we didn't talk about this, and I didn't talk about it because I don't think any of us really understand it at all yet, and we're starting to do some experiments here, is really dissemination and implementation. So in the end, if you get a really great idea, and you get really great innovators to the table, and you have a beautiful evaluation process, and you have the world's best program management, and you make a new thing. So it's a new approach to exploited people, or it's a new approach to the next, major trauma disaster that's coming down the road, and you're sitting with it, and the thing happens, and what you have hasn't been implemented in some way, it doesn't matter that you did it, right? I mean, I'm a doctor, I'm a very practical person. It only matters if it benefits somebody. It doesn't matter that you did it. It matters that you got it where it needed to be. And we don't think enough about how we disseminate and implement, and I think that that's a problem as well. So engineers do, because you make a gizmo, you got to get it somewhere. But I don't think that necessarily we do, because we get rewarded not for implementation, we get rewarded for publication. And we get rewarded by different recognition mechanisms where they have very little to do with putting things in the hands of a needy population. So that's the final and biggest and most important hurdle. Anyway, thank you for your attention, and I'd be happy to take questions.
We have a few more minutes for questions. Anyone who has a question, here is the microphone. Who wants to have? Yeah.
So my question is, what do you think about novel innovation, techniques like design thinking, which is being used in industries for already almost 10 years? I don't have a feeling that we scientists really implement it in our everyday lives.
Yeah, so I mean, I think, so there are many different kinds of design thinking, which is a question, and can we use that in scientific work? And, you know, clearly, yes, we can. And I think that there are strengths in all of these disciplines. I mean, there are a lot of, and I know that you will do in this course, one of the things you're going to get is an introduction to various different ways of thinking about innovation. It's not one concept. Design thinking, I think, is very useful. But in the end, and this is not a critique at all, it's an endorsement, in the end it all comes down to the same topics rejiggered, right? Which is, what's the problem? How do you, design thinking is really about trying to come up with, at an elemental level, what is the problem, right? That's the first step of doing design thinking. It's the same issue, how do you frame your question? So I think it's all the same, and I think for different people, for different groups of people, different structures feel more comfortable, feel more intuitive. And I think part of your work, I would think, during this course is to familiarize with yourselves with some different approaches, and then to decide how you actually will recombine those approaches for the unique problems that you face in the questions that you are either involved with or want to champion or see around you. And in the end, I think we're all probably best served by a mishmash of approaches.
Okay, thank you.
So thank you very much for this interesting presentation. And I was very intrigued by your observations that actually we are not able to deconstruct and frame our questions, which should be at the very core of our business as scientists. And so what is your personal opinion? Where lies the root of this problem?
So, you know, actually, I think it's interesting. I think that part of it, I mean, that's a long discussion and we don't have much time, but I think in talking to the people as the stuff came in, I think that over the past 15 years, the evaluation process has been increasingly focused on hypothesis, right? So what people say is, I'm doing hypothesis-driven work, or you get a critique back on a grant, and the grant says, this isn't sufficiently hypothesis-driven. And there is a really big difference, and that scientists have, they are distinguished from other people by being green or something, but also by having a hypothesis. But hypothesis is an answer, it's not a question, right? It's not, gee, what is the moon made out of? It's the moon is made out of green cheese. That's my hypothesis. So I think partly it's been trained out of people because what you're rewarded for is offering some sort of half-baked, often, solution. And then that's a prejudice that then extends to the rest of your work. You're walking around offering people solutions as opposed to saying, what's the question? So I think we've been trained to try to offer a hypothesis and not a question. But I don't know.
But isn't that the core thing? Because then you have a lot of concept, a lot of ideas of doing that, but that you need persons that are leading the thing, that are running the things that innovation occurs.
Yeah, I mean, there's a huge, and Linda's book is very good, by the way. It's very nice. She's really lovely and smart. Yeah, I mean, it is about leading it, although I think that probably leading innovation and managing innovation not totally synonymous, right? So I mean, I think there's one part that's sort of a bigger visioning thing for an entire effort, which is a lot of what she talks about, although she also talks about sort of the more granular part of managing it. And I think there's a part of that is really as simple as group facilitation, right? For groups that are very diverse and trying to do difficult things that may not be completely endorsed by the communities in which they reside and don't have really well-established paths for getting all the resources and information and personnel that they need to function. And remember, when you're leading a big multidisciplinary group, the likelihood that all your people report to the same person is pretty close to zero. So there are also just the difficulties of this. I mean, imagine I'm doing a project on mental health stuff, okay? And I used this example, some version of this example last night a little bit. So I've put together a new group to think about whether living in some sort of different structured setting might be good for somebody with schizophrenia or autism, or I don't even care what, right? So now I've got doctors, I've got social workers, I've got architects, I've got color theorists, maybe I've got an exercise physiologist, and somebody who does dietary therapy. None of those people report to the same person. All right, so all of them have to go to different meetings. They've got different sorts of issues about their budgets. They've got different metrics for their success. They all have different networks. Now I'm sitting there and saying, God, we really need a statistician. Where's the statistician coming from? Is it coming from the architecture school? Is it coming from the physical therapy department's budget? Is it coming from the doctors leading the team? I mean, somebody's got to sort of walk around and say, we need this. Where is it coming from? Who's going to vouch for that? Who's going to be responsible for it? Who's got the budgetary space to absorb this? I mean, it's a trivial example, but the leader of your whole team is not going to go figure out where the biostatistician's coming from. But an on-the-ground person is going to do that. And if the dietitian is somebody really motivated and says, Charlie in my group's a great biostatistician, I bet you I could bum 10 hours of his time, and goes and does that without any sort of supervision or integration, 3 months later, his boss is going to say, or her boss is going to say, what happened to Charlie? Charlie's supposed to be working on this. Charlie hasn't gotten his job done. And then all of a sudden your team looks terrible because you stole Charlie's time. Right. So there are all of these sorts of issues of working across multiple groups that I think aren't obvious as you set out. But it's really easy to step on people's toes and to alienate everybody else. And I think part of the on-the-ground project management is making sure all those wheels are turning in sync, not minimizing friction, maximizing forward motion. The leader of the big innovation thing is never going to have enough time to be that granular. So I think there are two things.
Thank you. I'll be short. I was just wondering on the collaborations, like encouraging it. It's very nice that you could reach like up to 70% increase. Do you have like follow-up studies? Like how long-lasting are these? Like do they have to be encouraged again and again with $800,000, or they're receptive for this?
So
Thank you.
We don't have enough numbers to really answer the question. The short answer is some of the groups stayed together and some of the groups didn't stay together. The important answer is why different groups did and how productive were they, and did they stay together and answer a different question because they liked working together in the end, or did they stay together and answer that question? We don't have enough follow-up yet, but it's an important question.